Good morning. I'm Lori Diamond, Associate Publisher and VP for GovExec's Defense Group. I have the pleasure of speaking with Lamont Copeland, our dear friend and Verizon's Director of Federal Solutions Architecture. In our discussion today, we'll deep dive into how 5G is used as an AI incubator for the DoD. Welcome, Lamont.
Hi, Lori. Thanks for having me today.
Thank you for joining us. So, Lamont, your career is so impressive. Can you share with us some details on your background and your role, what your role entails at Verizon?
Yes, definitely. So I've had the pleasure, I've been in industry for 24 years now. 16 of those years I've been working with the federal government in one form or capacity. And in the past 3 to 4 years, I've been in this role with leading the solution architecture team, which is delivering solutions against all the mission sets for the DoD. So basically what we're trying to make sure that we're doing is partnering up with the DoD all of its constituents to ensure that we're driving outcomes that are meeting that mission need. Because we're not just here to deliver technology. We're not just here to talk about, okay, what's the latest 5G craze, what's the latest AI craze, what's the latest zero trust thing. All those are components to how we're going to be delivering outcomes and solutions to any one of those mission sets that they have today. So, and we're trying to do this partners with the DoD. So that's one of the key parts that my team and myself are very focused on.
Excellent. So we're continually hearing about AI these days. So why does it make sense to talk about 5G with respect to artificial intelligence?
Yeah, no, and it is. It's a plethora of information, news articles, industry discussion, investment discussions about AI, the craze in AI. What is it? How does it support different missions? How does it support the war fighter? How does it support everything that's going on inside of the government today? And the key part of what 5G is with the AI craze that's going on right now is how it is that support element for AI and how it helps to incubate all the AI solutions that are being developed today and will continue to be developed over the years. And so you're probably thinking, so what does that mean? What do you mean? How does it support that? Well, think about this from the sensor side of the house. There are right now today about 7 billion sensors out there today in different forms of capacity, providing solutions for military, government, and civilians today. And that's supposed to triple up to about 25 billion by 2030. And all that sensor information that's coming back is coming back into different cloud infrastructures and into different AI solutions and large language models to be able to then, take that data, smush it into different outcomes and different things that data scientists are looking at to try and answer specific questions and specific needs, and then going back out to the sensors or out to other individuals to be able to support that. And for that to happen, those large language models need to have a means to be able to access that data. And that's where the 5G comes into play to be able to help be that underlying infrastructure to move these terabytes of data that are going between sensors and edge cloud and far cloud, which house these large language models to be able to then support that. So take that into an example of like with the DoD, where you have these a natural disaster or some kind of event that's happening on the coast side, on the U.S. side. They're going to always deploy National Guard. The military will be deployed out to be able to help support all the recovery aspects, help with the support necessary to get and move through that disaster, whether it's a hurricane, fire, etc. So what's going to happen is you're going to have these different sensors that will come into play, which will provide information, weather data. There'll be what's happening with the event, what do you see on the ground, what type of news feeds, what information and situational awareness is coming into play. And all that information will be coming into these command centers or into these data centers. And depending on how the data scientists set up those models to be able to take in all this information, both in a structured and unstructured data standpoint, that will then be, mushed together, figured out how then you would take that and provide different insights and outcomes, which would then support those ground troops that are out there to be able to support the citizens or other public safety and other folks that are part of that disaster recovery. And that's going to take in data from different, things like drones too as well. It'll be visual data, it'll be textual data, but all that information is only resonant and can get back to the networks into these clouds through a 5G connection or through a wireline, a 5G to a wireline connection back to these data centers where clouds where all this the AI is being hosted and supported. Then also take it into the standpoint of an example of like if a tactical deployment to it as well. There you can provide like a private 5G bubble for these soldiers to be able to work in theater, to be able to then take similar, just like you talk about the CONUS natural disaster with the National Guard coming out. Take that for a soldier, airman, a Navy person, whether it's in theater on the ground or on a ship, being able to communicate. There's millions and millions of sensors on an aircraft carrier, in a drone, in satellites to be able to feed information, situation awareness, crunch that data through the AI system, and then move that back out. And that's all being transferred over these connections to be able to support AI outcomes.
In some of our previous conversations, we talked about lab settings. So how can 5G specifically act as an AI incubator?
Yeah, and with those use cases, those aren't something that are just done in an environment. It's not just something that you pull together really quickly, say, oh, this will work, and then, put it out in the field and do that. This is where, Verizon and other carriers, we have these labs that are across the U.S., which will then be able to bring in the sensors, bring in the data elements, able to bring in these large language models, and then be able to test and see, okay, how do I tweak the information that's coming in? How do I know what the parameters and the performance that's necessary to be able to communicate with those edge sensors, and then have that data come in? What's the right data that I need to be able to look at? Because when you look at that and you talk about terabytes of data, these models can become huge. And what the data scientists are looking at is, how do I then take what data that's relevant and then make sure that I'm using it accordingly to be able to drive those sensors to be able to do specific actions afterwards, after they provide some certain information, whether it's visual or textual, or you can provide that information and put it into the right format and then send it over to the general or to an admiral to be able to say, here's or commander, here's what I need to be able to do to provide different actions that are happening there. So these are all then, this is where these labs and where AI and 5G are coming into play, is to say, how do I look at that end-to-end system, end-to-end solution, and how do I then take that into these labs, continue to tweak and move around how this information is consumed, the type of performance, how do I then chunk this information into different components to be able to feed into these large language models? How do I then figure out the right language model that I need to do? Then how do I then also, tying it back into the network itself, how do I then make sure that the network is reacting and performing to the means necessary? How do I then say, with these models, I can then go, oh, now I need this sensor to be able to provide different information and then provide specific outcomes, but I can then take that and then drive it into the dynamic aspect of the 5G spectrum itself to be able to provide me more bandwidth, provide me, when we have more things with network slicing, to give me a specific slice for protection, to be able to have my own communications channel necessary to be able to support whatever mission set there is. So that's really where the power of these labs is coming in, allowing different parts of the DoD to come in, look at how we manage the network. How do we make sure that network is providing that connectivity and that the support necessary for these sensors? And then how is also providing, the connection and the understanding of the, where these models are being housed and the resources necessary to be able to support the outcomes that the military is looking to do.
So you mentioned how the testing is done in a clean and pristine lab situation, but how do you bring that testing out into the real world?
Yeah, so what's fun about that is then you start doing these different stages. So take it, for example, from the tactical environment that we were just talking about before. What you do is you bring that into a lab, and it can be run into a public 5G environment, and talking about these different, man packs or deployables that are put onto a soldier's back to provide different sensor information. Or it could be done in a private instance where I'm then building a private bubble where the 5G and only specific communications is happening with people who have access to that. Or it could be a mixture of the two, where people can move with the right access rights into those in and out of that bubble. How that then is looked at is after that testing is then, especially with the tactical environment, I can then take that and move that and run this in through the different places like at Quantico and go through different, the test fields and seeing, okay, how does this really work? And how do I then start trying to make sure when I'm talking about it in a public standpoint, having a controlled use of that spectrum and managing and looking at the environment and saying, okay, here's what's happening with it in more of an in-theater play before we have to do it with live fire or live action that's happening in a wartime standpoint. So it's really taking it from like our labs and where we have these IMS cores, these large cores which simulate the network, same type of spectrum, and then just taking it and moving it into where the environment is, moving it to the bases, and then where we have and working with the DoD right now to get 5G built into those bases, saying, okay, here's how it then looks inside of this environment, if this controlled defense environment, to say, okay, this is what it would look like. How do we then start doing more tweaking, more testing? Do we need to bring things back into the lab? And then from there, being ready to be, hopefully we don't have to, but ever be able to use it inside of theater as necessary, but having it ready off the shelf to pull it off and ready.
So can you share with us some applicable use cases where we can kind of visualize and see how everything pulls together?
Yes. Yeah. So, and I'll draw on one of them right now where I was talking about with the Navy. And we have our example right now down in Miramar, where we're working with the Defense Department and the Navy to be able to test out how 5G with our public network we'll be able to leverage for AR, VR for testing of and training of the soldiers themselves and having that real-time feel of different situations. How we're using it for robotics, because there will be the time to use it for a defense standpoint, from a security standpoint, where you can have it manning perimeters, doing things for bomb checks, those things in nature, to be able to look for anomalies that are out in the field. But then you can also use it for things in smart flight line as well. Those are some different scenarios that we're using it where you're having it with that digital twinning to be able to see that information, be able to do testing, be able to do environmental views of how I would then build a ship, build that repairs of a plane and that stuff, but then tying all that same information for those airmen and sailors that are trying to then do some repairs to say, hey, okay, here's what I need to do. Here are the manuals, but here's my inventory, and having all that in a visual standpoint and be able to pull that together, whether it's at the base or someplace out in the theater. So those are a couple of examples. But then also too, there's a lot of different medical aspects of this as well that we're looking at with the different things to help support the soldier. So how do I then take that same type of technology and put that into sensors that are looking at and looking for health anomalies, looking for things to help with things like doctors to be able to see how do I get information from different files while I'm doing surgery or doing telemedicine for something that's remote, and getting more of that personal feel, personal touch, using the virtual reality to be able to support that, being able to see information like we're more so than what we're talking like here on the conference bridge that we have right now. So really trying to pull more of that personal feel but more information to be able to then provide the soldier, whether it's in field, in a rural location, or even at their home, a way to do telemedicine in a different and more humane way for them.
So looking to the future, what are the overall challenges that the DoD will need to tackle regarding AI?
Yeah, and there's a lot of things with AI as it kind of moves forward today. What the data scientists are going to be is that they're going to have to work through is what are the right language models that they're going to have to be able to play. There are so many out there today, from the Chat GPT to regression encoders and things of that nature. What are the right language models that are supported to be able to do that? There's other elements with the housing of the data. one of the key parts and one of the main things that we're always protecting on is where is this data housed and how is it being used and how does it get out to there? As things like the JADC2 get stood up and we get more of these cloud environments, how do I then protect the transmission of that data and the housing of that data so that then they can leverage the power of these GPUs to be able to do the computing necessary that's needed for these language models, especially when you talk about terabytes and terabytes of data coming in, and how does that then get mixed? So, there's those challenges of, being able to get all these resources that are necessary to be able to do large scale AI models and AI support. And then, then there's just, what is the right questions and things that need to be answered with AI? Because when you're doing this, there's a lot of training that goes into play, but it's a lot of also what are the expected things that you want that to be able to go through so you can then train it and get it smarter to understand, and also make sure that it's not doing things that you hear called hallucinations where it's giving you bad information based off of what we have. So there's a lot what they have there. But what's good about that is there's a lot that they have to figure out there, but from the network side of the house and how we get that data there, the 5G is going to be there and available to be able to make sure that they have that connectivity from those sensors, all that information, and be able to get it to whether it's an edge cloud itself and doing it really close for that real-time communication and getting it back to the sensors, or getting it back to the far cloud where you have a lot of that compute power to be able to support the choice of whatever language model they have in that data there. So we're pulling out the choice and the challenge of how do I make sure that these large language models are connected to that data when we have that connectivity available to them, have those cloud resources, and then being able to support the movement of this data between the end to the models and back. That's what we're making sure that they don't have, so they can focus on how they deliver on the mission, how they deliver on the information that's getting back, and how they deliver on the outcomes that they're trying to achieve with these AI models.
Thank you, Lamont, for once again sharing your valued expertise with us today, and thank you to Verizon for making this workshop possible. Up next, Defense One's Patrick Tucker is returning to talk about the Army's cloud efforts with the Army Enterprise Cloud Management Agency. We'll talk to you soon.